welcome to the next game programming tutorial in Java. So I'm continuing this from what was a classroom type of environment, I guess, classroom environment learning game programming in Java. I'm kind of moving that to now just a video thing so you can go at your own pace and I can present this a little bit clearer than I was in that classroom environment. But if you're joining me from the classroom environment, that stuff's not just going to go to the waste. We're going to start exactly where we left off. But if you are not joining me from that classroom environment, I think this is a fantastic starting point anyway. If you want to, you could watch the all three of the classroom tutorials I had, which were just kind of in class. We went through this from complete scratch. But another thing you can do is you can start off right where we are now, because right now we've kind of left all of the kind of ridiculous Java graphics library stuff, and we've moved more into our own kind of thing. So now we're really creating our own thing, and we're getting right into the game programming and less of just the Java programming. So that's the main thing here. And you can go ahead and download the source code for lesson 3 and start right here. I'll just download the Java files from here. This is at my website that is currently, well, that's not my website, that's because I'm on the same connection as my server, so I just connected it that way. But yeah, that's marcusman.com. That's like that, but I can't connect to it from here. But yeah, that's marcusman.com is my website. You'll get right to here, unless it's changed. If it's changed, I'll put a annotation or something here to where you can access this stuff. But you'll have a few different folders here. You have lesson recordings for all 3 of the lessons we've had so far. And you'll have the source code, and these are the workspaces for each lesson. I say last resort because I want you to check the recordings first and try and figure it out yourself. But if you're starting from lesson 3, you need to go to this folder and download the lesson 3 workspace. So just download everything that's in this folder. So anyway, yeah, we're going to start there, but we're first of all going to start with a real quick recap through what we've done so far. So right now we have two Java files. We have the game class and we have the render handler class. And the reason that we have 2 classes is because the render handler is really here what's going to be, we're trying to prioritize our classes a little bit more. We're trying to, not prioritize, but we're trying to be a little bit more organized. So the render handler is going to have everything to do with rendering, which is probably going to be quite a lot, because there's quite a lot of stuff we got to do to get things to be put into pixels on the screen. So if you're starting out here, what we have here is simply something where we have control of all of the pixels in a frame. So if I run this, right now as you can see all of the pixels are randomizing, and it's all randomly, and it's kind of hard to look at actually, so I'm going to get rid of that. That's because of this part here where I just randomly set every single pixel. So we pretty much have access to every pixel on the screen from what we have going on here. And the way we're doing this, the best way to figure out the way we're doing it is to maybe even just skim through the 3 recordings, lesson 1, 2, and 3. Maybe not copy all of it down, because really all you had to do there was copy stuff down. I was just teaching you how Java deals with graphics. And I don't necessarily agree with some of the stuff they do with graphics. It takes quite a long time to actually get to the point where you can control what's on the screen, which I think is a little bit ridiculous. But yeah, pretty much what we have going on here is we set it so that our application will actually shut down when we close out of the JFrame. So that's what I have going on here. We're setting the boundaries of the JFrame. This is the X position, that's the Y position, this is the width, and this is the height of the frame. By the way, JFrame, that is the Java frame class, pretty much. We are creating a frame here. So we're extending the JFrame library, which means we have access to every single JFrame method in this code. That's why I'm using setBounds and setDefaultClose operation as if they were methods in this class, because we are extending JFrame, which has all of these methods. And we are implementing something called a runnable. And implementing runnable pretty much means this is a type of runnable, which is something that can be run, pretty much, something we can run as an application. And I know you can do this normally by just running a main method or something, but this gives us a little bit more control over our thread, and a little bit more, it makes our game a little bit more stable later on. We'll probably get back to that a little bit later. We're going to not worry too much about that yet. What else is going on here? Yes, we're adding something called a canvas. And a canvas is something that we can paint to. Just kind of like a normal canvas in real life. You can use a paintbrush to paint to a canvas. We can use our code to paint to a canvas in Java. You can just change the pixels and figure out what we want to do. And so we're adding that component to our JFrame by calling the JFrame add method. Oops. Sorry about This set visible true legitimately just makes our tray frame visible by calling a method called set visible and passing in a parameter that is a boolean. What else are we doing? Creating a buffer strategy. Now this is where it gets a little bit complicated, and you're probably going to want to watch the previous. I think that's actually just the lesson 1 of our. Yeah, that's lesson 1 of our of this series. If you want to figure out what buffer strategy is, pretty much what this is it's graphics buffering. So instead of drawing to the screen and having the player see the pixels actually being drawn to the screen, we are buffering the draws. So we want to make sure the player only sees a complete image of what's on the screen. And we do this by painting to a buffer that's off of the screen and swapping those buffers. And if that didn't make any sense to you, you're probably going to want to watch lesson 1. And then, of course, we create our render handler. And our render handler, which is what actually renders stuff to the screen, this is how we deal with that, simply takes 2 arguments, and that is the width and the height of the screen. So we pass that in, and it creates something called a buffered image, which is simply an image with a buffer. It's an image that we can edit, we can change, and we can use in different types of varieties. We can use it to draw to the screen. We can use it to combine it with another image. We can draw to the image. We can do a lot of stuff, and that's why we're using a buffered image. Okay, so that just takes width, height, and a color strategy or color type. I'm trying to think of the word. It's just a type of color. So we have RGB. You can also use ARGB. I think BGR, whatever you want to use. It's kind of just whatever. We're using RGB because we're not going to be dealing with alpha, which is like alpha is just like the transparency of the image, but we're not going to deal with that right now. We also are creating an array here of pixels. Now this line of code looks ridiculous, and that's because it is ridiculous, and I do not expect you to understand it, okay? But all this does is gets the pixels of the image in an array. Now, and you might be saying, how can you put pixels in an array? Well, this is done pretty simply, and actually I'm going to go ahead and use paint.net as my example here. I think I actually have an image open. Yeah, that's RuneScape right there. That is old school RuneScape. Anyway, so what we have here is our screen, right? And let's go ahead and just say, let's see, adjustment, let's go ahead and just render a grid here. Grid lines. Okay, so I'm going to make our pixels big here, so big. So all of these are my pixels. Now what's going to happen here is the first part of the array, array 0, is going to be that pixel right there. Array 1 is going to be that pixel there. Array 3, pixels 3, it's going to be there. And then array width is going to be, well, the last one here, so 3. Well, actually, you have to account for the part of the array that is 0. So this is actually going to be the area of width minus 1, because we are dealing with 0-based arrays and not 1-based arrays. In other words, this pixel here is going to be pixels 0, not pixels 1. So this entire line here encompasses array width. And that's pretty simple to understand. So pixel 0 is there, pixel width minus 1 is there. The next line is going to pick pixels width. Yeah, pixels width, because this is pixels width minus 1. This is pixels width. This is pixels width plus 1. This is pixels width plus 2. So that's pretty much how you deal with pixels here. It's the array kind of just takes the next line of pixels and puts it on the end of the array for each line of the screen in pixels. So that's how we're dealing with pixels here, and that's how Java deals with pixels, and that's how I think actually it's a pretty good way to deal with pixels. All in an array. To sweep through them, you just kind of have to stop at the width. For example, if we wanted to only set one width of code to be random here in this for loop, we would just go width, or whatever our width of our screen is, which we'll have to figure out. So there's a render handler. So now down here, we have a run method. Now this is for runnable. So this will get run whenever we start our thread, which is down here in the main method, which actually starts the application. Now, the weird thing we have going on here is we're creating our buffer strategy, which is the graphics buffering, and we're dealing with time. Now, here's the thing. One thing we don't want to have happen is we do not want our game to run differently depending on what computer you're running it on. if I am on a Skylake i7 GTX 980 Ti, I don't know, friggin' amazing computer for at least, I mean, right now, that would be a good computer, depending on when you're watching this video, I guess. But then it's probably going to run pretty fast. You know, if we don't have some sort of limit, that's going to run pretty fast. What we don't want to have happen is have the player movement be faster on that computer than it is on a much slower computer. And the way we do that is by dealing with time. So, one thing we do want to have happen is we do want to still, we still want to try and get the full power out of that GTX 980 Ti Skylake A7 computer that's really fast. And the way we do that is we have two methods, right? We have the update method, which happens the same time on every computer. And we have the render method, which happens as often as possible in every computer, okay? So, in other words, all of the stuff's going to be rendered to the screen as fast as the computer can handle it, which is cool because if you have a better computer, the game's going to run and look faster. It's not going to hitch as often. But the player is going to move at the same speed. Objects aren't going to shoot across the screen on a much faster computer because of the update method. The update method is going to update our screen, or not update, sorry. It's going to update our variables the same amount on every computer, depending on the amount of time that is changed. So, if you want to figure out how this, I told you what these methods do. If you want to figure out more how this code works, if you can't figure it out by looking at it or reading the comments, you're going to want to have to, this part was lesson 2. So watch lesson 2 for this part of the code. And this down here is a bad loop. I'm going to go ahead and get rid of that. That's what we used before. So that is pretty much it. That is what we've done so far in lesson 1 and lesson 2 and lesson 3. In lesson 3, we did the render handler stuff, if you're wondering, because I talked about lesson 1, which was kind of just getting this all set up. Lesson 2 was this run and render and update, and lesson 3 is the render handler. So, now that we've got this all in place, let's move back to our presentation here. Now, I'm really not going to spend long on these presentations, mostly because they are boring, but we do need to talk about a few things. And that is, I'm going to go ahead and bring back our buffered image slide so we can figure out what this is. What we're going to try and do this episode is we're going to try and import assets. So what all we have right now is pixels, right? We have pixels we can mess around with. And actually, let's go ahead and mess around with a few things before we actually get into that stuff. So, right now, as you can see in our render method, we are sweeping through every pixel in the array, and we are randomizing it. This is actually the maximum value the pixel can be. In fact, I can show you what this is by printing this out. You don't have to do this. I want to just print this out for you so you can see what this is. So, that is the maximum pixel you have. That is around 16 million. Or I guess 17 million, but yeah, that's the maximum color value you can have. And I think actually I have too many F's there. I think I still get the same number if I do that. Yes, I do. So I think if I take one more away, you get... Oh, maybe not. Wow. Oh, I know why. Yeah, I know why. Never mind. Forget anything I said. This is hexadecimal. I still have trouble understanding hexadecimal sometimes. But yeah, just know that this is representing a number, and this number is the highest pixel value you can have. Now, what exactly is a pixel value? Now, pixel value is simply a number that represents a specific color, and there are evidently 60,777,215 different colors you can have. Maybe plus 1, because there might be a color 0, which I think is just white. So, yeah, I guess 60,777,216 colors you can have. But, yeah, this is just our maximum color, and we're multiplying that by a random number between 0 and 1. So, kind of we just get a different range of color. Now, this is happening every single time the render method is called. If we do this up here, if we just copy the whole thing up here, where we actually create the render handler, that's only going to happen once. So what we'll get on the screen is a bunch of random pixels. Oh, I actually have to compile. What we'll get on the screen is a bunch of random pixels, but they won't actually change because it's not in the render method. So, yeah, that makes it not kind of jump about randomly. Now, let's mess around with these pixels a little bit, though. Why don't we try something else here? Let's try and randomize every line of color. So, like, instead of having random pixels all over the place, sorry, instead of having random pixels all over the place like we do now, why don't we have a random pixel for each line? Just to mess around with what we can do with pixels here. And this isn't just me messing around. This is going to help us understand what to do here. So let me go ahead and zoom in, because I can do that pretty easily. And I might start, I'll try to get in the habit of doing that so you guys can see this easier. So, yeah. So right now, our index, we're starting at pixel index 0, and we're going to the length of the pixel array. Why not instead we go to the width of the screen, which we're passing in here. And then we have a random pixel for each width. Except we're going to have to do this a little differently. We're going to have a random pixel here. I guess, how should we do this? Hold on. Okay, this is what we're going to do. We're going to loop this for all the height of the screen. Okay, this is going to get a little tricky. We're going to have nested for loops here. I wanted to not have nested for loops, but oh well. So, we are definitely going to have to mess with nested for loops. I just didn't really want to start with that. So this is going to be our random pixel. So right now we are going through each height index. I'm going to go ahead and rename this variable to height index here. So we're going through each height of our screen, and for each height of that screen, we want to loop through every pixel of the width and set that pixel to whatever the width is. So we want to go ahead and create another for loop here, a nested for loop within a for loop. Width pixel width index is going to be 0. Width index is going to be less than width, because this is a 0-based array. If it was less than or equal to width, then we would go on to the next line. And then we want to do width index plus plus at the end here. So now we have a random pixel for the height. We want to set that for each pixel in that width. So the way we do that is we do pixels, and the array type, now this is where it's going to get a little bit tricky. We want to multiply our current height index by the width of the screen, okay? Now the reason we're doing this is because let's say we are on this line, right? Sorry, let's say we're on the line where the blue pixel is. Sorry, the blue, there. Let's say we're there, right? Now we can't just say this is pixel of width index 0, because that's not going to work. Unfortunately, this isn't a system where we can say x is 4, y is 4, and we're there. I'm hoping that we can implement something like that later, but right now, we have to actually take account for all of the other pixels in the other lines. So this pixel is going to be the width plus 0, because this is just pixel 0. This is going to be the width plus 1. It's going to be the width plus 3, width plus 4, and so on. Down here, this is going to be 3 times the width plus 2. It's going to be 4 times the width plus 2, 5 times the width plus 2, and so on. So yeah, that might be a little difficult to understand. Pretty much we have a linear array for something that is actually 2-dimensional here, because we have the x and we have the y, but this is all put into one-dimensional array. So yeah. So we have height index times width, and we want to add the width index to that here. So we are offsetted inwards by the width index, but we're offsetted downwards by the height index. And we're going to set this pixel to our random pixel. Okay? Let's make sure I don't have any errors. Looks like I do have one error. Oh, this needs to be height index up here. We can go ahead and space this out a little bit to make it look a little nicer. And yes, I do have the bracketing method, which is putting the brackets on the same line as the I guess the C-style bracketing method, where you have the open bracket on the same line as the identifier. To make it easier for you guys to read, I'm going to go ahead and try to force myself to do this other type of bracketing method, which I do agree sometimes makes your code easier to read. So yeah, I'm going to go ahead and do that. And I think, yeah, I forgot to do it here as well. So let's go ahead and change this around if you like it that way. And then I think we're good. Okay, so let's go ahead and run this and see what happens. I don't think it compiled correctly yet. There we go. So, as you can see, every line here has a different random color, but it's not just random pixels all over the place. And that is because we are looping through every height, and we are looping through all the pixels of a width, and we're setting that pixel to whatever our random pixel is, but we find the random pixel up here before we actually loop through the width. So yeah, that's how that works. So now that we've done that, let's move on to our implementing assets and stuff like that. So buffered image. I just want to, this is recap from lesson 3. I want to go ahead and go through what a buffered image is, though. A buffered image is essentially just an image of a buffer. It allows us to edit all of the pixels in the buffer, which is really the main thing that we are using the buffered image for. It's comprised of a color model and a raster of image data. Now, a color model is simply something that represents our components here. So pretty much we give it, okay, we want this to be an RGB format, red, green, blue. And then it's like, okay, that's fine. We'll any time we deal with this image, we'll be dealing it in RGB, which is the simplest format, I think, to understand, which is just like random colors, or it's not random colors, but you know, color IDs between 0 and 16 million, or 17 million, I guess, around 17 million. Another color model example would be RGBA, which is just it also accounts for an alpha channel, which is just transparency, which we're not going to be dealing with. What else we have is a raster of image data, and that's just a rectangular array of pixels, which is the pixels array which I already talked about. It's just a data buffer which stores all pixel values in an array. And also, don't worry about the sample model. That's just describes how to locate the pixel values, which we're not going to worry about because I just told you how to locate it by default. So now, importing game assets. So by importing game assets, I mean actually importing pictures and getting them on the screen and stuff like that. So ImageIO. ImageIO is something in Java that we're going to have to use, which is essentially just stands for image input/output. And this is a library that allows us to input images and output images from our storage system. Every class in Java has the ability to get resource, and then the path of the resource, which just retrieves the resource at path as something called an input stream. Now, an input stream is exactly what it says. It's a stream of input. So if you have a file that is an input, this is a stream of data from that file. And that's, yeah. An object representing a file that we're reading is an easy way to think of it as well. ImageIO.read input stream reads an image at specific input stream. So it reads that image to a buffered image. Pretty much this is how we're going to get our buffered image from a file. By the way, I already talked about this, what a pixel array represents. If you need to figure out, this is that the width of this is going to be 10, because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we're stopping at 9 here because this array is 0-based. That's what makes this a little bit difficult to understand. But yeah, that's what our pixel array represents. So anyway, let's go ahead and import some game assets now. Let me just go ahead and open up something here. Give me just a second. All right. Hold on a second. Okay, sorry, I just had to get a little file open there for a second. What we're going to do quickly, before we start with importing images, we actually have to get some images. Now, if you go back to my website, marcusmann.com, or if you go to any kind of, well, whatever the website will be later, I don't know, it might still be marcusmann.com by the time you're watching this video. If I don't have an annotation, it is marcusmann.com. But what you can do is you can either make your own images, you can find free sprites online, or you can use these, as long as you give credit to these 2 credit links. Here is a grass tile. Here is kind of a sprite sheet of tiles, and here is another sprite sheet of tiles, which we're going to use. I'm going to be using these for these tutorials. Here's the credit if you're going to be actually using this as something that you publish. But yeah, go ahead, and now we're just going to go ahead and download the grasstile.png, and we're going to save this to our workspace. Now I happen to have this workspace in a very odd location, so give me a second. Game programming tutorials, workspace, grass tile. So I saved that to our workspace, and that is right here. So we have grasstile.png in our workspace. Now what we're going to do is we're going to go back to our game, and we're going to create a method here create this method, I guess, wherever you want. But what this is going to do, oh my gosh, I'm doing the C-style bracketing here as well, so let's go ahead and fix that for you. We're going to create a new method, and this is going to be a private method, actually. This is going to be returning a buffered image, and the method's going to be called loadImage. And this is going to take one parameter, and that is the path of this image. So what we want here is we want to be able to call this method wherever we want, like up here. So test image. What we'll do is buffered image, test image equals load image, and then the path of our image is just grasstile.png. Yeah, grasstile.png. So that's what we want to do. We want to be able to get an image from that. And we're going to do that all in this method. So if you remember what I talked about, any class has something called getResource. But first of all, we have to get the actual class instance of this. Now, this might seem a little weird, but we're actually getting the class instance, which is the object of this. We do game.class, capital G for the game, dot get resource, and then we have to pass in the path, like that we have up here, the path parameter. So this will just get the resource of this path as an input stream. Okay? Now, we're going to have to go ahead and import a few things. Up here, let's go ahead and import... Sorry, what are we importing? We need... do we need anything? We need image.io, I think. Yes, we do. Sorry, image.io, that's what we need. I was like, we need something, I know. Let's go ahead and import javax.image.io.image, or IO, and that's the caps there. You have javax.all lowercase image.io dot capital I and then capital IO at the end, because IO stands for input output. And those are all different words. So, yeah, that's what we're doing here. We're importing image.io, which we're going to use in our loadImage method. So, the reason we're not importing input stream is we're not actually going to create an input stream instance. We're just going to go ahead and image.io.read, and then this. We're just passing in that input stream. We're not even worrying about it within this class. We're just going to pass in game.class.getResourcePath. And if you're wondering why I'm saying image.io.read, is because this actually returns an image, which is pretty cool. That returns a loaded, well, I'm calling it loaded image. This is the image that we're loading. And this reads it from this resource that we have. So, you might think that's it. There's a little bit more we have to do. One thing, if you compile this, that you'll see happen is, actually, we need to import buffered image, my bad. That's one thing. That wasn't what I thought the problem would be. So let's go up here and import java.auth.image.bufferedImage. That's one thing. The error we are going to have is there's unreported exception, IO exception, must be caught or declared to be thrown. Now, to some of you, this might be like, wait, what? You were throwing? What are we throwing? I don't know what we're throwing. Oh, also, we have a missing return statement because we're not returning the image yet. We have to do return loaded image. And now our only problem is going to be the must be caught or declared or whatever. You're probably like, what is this? Who is this madness? I don't want to throw anything. I mean, programming can be a little bit, a little bit annoying sometimes. I don't want to throw anything. Yes, so I thought I had a slide on this. Hold on a second. I think I do. Maybe I don't. Okay, well, I'm going to have to teach this on the spot, which is okay. I'm okay with this. Okay, so what we have to deal with is something called a try and catch statement. Now, try statement pretty much tries a line of code, but if for some reason this resource doesn't exist and image.io can't read the image from this resource, it has to have something to figure that out. Like, it's not just going to crash the code, right? This is actually something really smart that Java does, and if there's an error within our code, it'll figure it out. It'll actually figure it out and tell us. So that's really cool. So how you format this statement is you put in something called try, and then you have whatever we're doing, and then you have catch. Now catch will catch whatever error happens within this code, if there is an error that happens. And the type of error that we're catching is down here, IO exception. So go ahead and put in IO exception here. This is kind of like a parameter for a method, so we're going to have IO exception, exception. And we're going to put this down there as well. And the IO exception that we're catching, we need to do something with that. Now just go ahead and put this in exception.print stack trace. Now what this will do is essentially print this exception to the console. So we know what's happening. Now the reason why you're saying, well, why, if this is the case, why don't we just not have a try statement and instead just have it crash but give us the error? Well, the thing is, hopefully it's not going to crash. The entire program this time is not going to crash with this framework. Instead, it's going to continue doing what it's doing, but it's going to stop doing this. It's going to say, okay, we had a problem with this. We're going to go ahead and print that error, but we're going to go ahead and continue the program because we can still go, even though we're having some troubles with this load image part. We're going to go ahead and continue our code. So that's what we're doing with this exception. Another error this is going to give us now that we've caught the IO exception is, first of all, I need to actually import the IO exception as if we were importing anything else. And that is simply, I'm going to go ahead and space these out actually. So we have java.op, we have java.lang, we have javax.swing, we have javax.image.io. And then there's also a java.lang, or sorry, java.io, just java.io. So import java.io.io exception. Now I'm organizing my imports here. And the reason you might say, well, why don't I just do java.art.star? First of all, you're importing things you don't need, and second of all, if we're importing different things from different locations, sometimes that can, some things can override each other as far as naming goes. So this, that helps with that, because this is such a bigger project, and we're dealing with much more information than we would be if we were just like doing a simple like programming project or something like with AP Computer Science or something. But yeah, that's one reason. And another reason, actually, a third reason, which I hadn't noticed of, I must be the Spanish Inquisition or something. Another reason is that we actually get to see everything we're using here. You might not think about this, but if someone else is seeing your code, they get to see, oh, okay, so this is all the stuff we're actually dealing with here. So it's easy to understand all the stuff that we're dealing with as far as Java goes. So yeah, we're importing IO exception. But another error we're going to get here now is we're missing a return statement, because if everything goes wrong, we're not actually returning anything. So what we can do is in this catch statement, we can return null if everything goes wrong. So if this goes wrong, it's going to print the error, and it's also going to return null, because we have no image to load, so we have to return nothing, unfortunately. Okay, so this is cool. We've got a loaded image, but there's one more thing we have to do. Now, buffered images that we load from a file, this is going to be in whatever format this image is in, right? Sorry, that's on the wrong monitor. It's going to be in whatever format this image is in as it imports. And unfortunately, this format is going to be ARGB format, which I don't think you can see in here. I don't think you can. But it's going to be a different format than what we want for our screen. So we're going to create another buffered image here and call this formatted image. Okay? And this formatted image is going to be a new buffered image with the, and these are the parameters for the buffered image. We have width, height, and the color model. The width is going to be the width of the loaded image. And you call the getWidth method that's part of buffered image to get the width of the loaded image. The height is going to be the height of the loaded image. And the color model is going to be the same as we had for our game. And that is bufferedImage.type_int_RGB. And that's in all caps, because this is just a static field in buffered image. And that is the formatted image. Now here's the thing, we've just created a blank formatted image that is the same format as our screen. Now we actually have to write our data to that formatted image, and we can do that by getting the formatted image buffer graphics. So let's go ahead and do that. Let's get formatted image dot get graphics, which just gets the graphics for that image, and we're going to do dot draw image, and we're going to draw our image and the location of the image, the loaded image, to the formatted image is going to be 0, 0, because we're just drawing the whole loaded image to the formatted image. And then this last argument, don't even worry about, just put null. If you want to figure what that is, you can figure it out on yourself, by yourself. But yeah, this is what we're doing. We are getting the graphics of this formatted image, which is the same format as our screen, and we are drawing our loaded image to that formatted image. And then we want to go ahead and change this last thing to be return formatted image instead of return loaded image. So I think that's pretty cool. We are loading our image, and we are formatting our image to what we want it to be, and we are returning that to an image. And the cool thing is we can call this same method to load any image that we have outside of this application, which I think is really cool. So now we have this test image up here, which is going to be a buffered image of grasstile.png, which we have in our directory. The reason that it's just type that in is because it's in the same directory as game.java. So yeah, and we're passing that in, and we have it as the exact same format as our game. So pretty cool. All formatting is dealt with down here. That's all it is. It's a lot simpler than you might think it would be. So I think that's pretty cool. So now we have our test image. With this test image, we want to draw this image to the screen. So first of all, I'm going to go ahead and make this a field, private buffered image test image. And that's going to be empty because we're sending it down here, kind of like we are with the renderer. And we're going to go ahead and create a method in render handler now. And this method is going to be called render image. Okay? Public void render image. All right. So now we're kind of parameterizing things that could be a lot harder than they are. What we want to do is we want to get the image data from this image, and we want to render it to the screen. We want some parameters for this render image. We want the actual image we're rendering. We want the X position of the image, and we want the Y position of the image. Okay? So, and there's a few things I'm going to give you here. Another thing we want is we want to copy the code we have up here for getting the pixels of the view. I want to copy that down here to get the pixels of the image, and just change view to image. And we want to actually tell it what this is. So this is, go ahead and call this image pixels, and with camel casing as well, of data buffer int. And just don't worry about this. It's just getting the pixels of an array of the image. And once we do that, I want you to go ahead and, in a second, I'm going to ask you to do this yourself. Try this yourself before I tell you. So I'm going to go ahead and give you a hint here. This is going to be a nested for loop. And this is, I'm going to start you off with what the nested for loop will be. So here's the first part of the nested for loop. I'm sure you can guess what the next part of the nested for loop is going to be. We're going to get the width of the image. I'm going to increase that. And I need to do this not C style. So that is our nested for loop there. Now try to figure out what's going to go inside this for loop. Pause the video, read these lines here, and figure it out if you can. And if you're wondering what we're trying to figure out here, we are trying to draw this. We're trying to put these pixels into these pixels at the specific location that is given to us. Now, this is going to be hard for those of you that have never done something like this before. But for those of you that have, and you've accomplished this, that would be pretty cool. So I'm going to go ahead and show you what we're going to be doing here. First of all, yes, we're going to be dealing with pixels. But first of all, I want to go ahead and figure out what part of image pixels we are dealing with. Now, the part of image pixels we're dealing with is obviously right now we are looping through the image, right? This is the image.getHeight. This is not view.getHeight. We're not dealing with the height of the entire screen, just the height of the image. And it's the same down here. We're not dealing with the width of the entire screen. We're just dealing with the width of the image. So, right? That's how simple it is. We're just getting the Y position, the height, kind of like we did all the way up here when we randomly and dealing with all the pixels. It's the height index times the width. It's just y times the width plus x, which is our width offset, which we have going on here. So that's the part of the image. The part that gets a little bit more difficult is the part of the screen we're dealing with. We have an x position, we have a y position here, right? So I'm going to give you a hint. This is what it's going to look like. If you were having trouble with it earlier, try to figure out what is going to be inside these parentheses. It's going to be a lot like this, just a little bit different. And this is setting the pixels of the screen, not the pixels of the image. So pause the video now and try to figure that out. In the meantime, I'm going to have a drink of my Coke. Some good Diet Coke. All right. So, I'm going to go ahead and tell you what this is. X plus X position, Y plus Y position. If this was just X and Y, it would render this image at 0, 0 on the view. We're adding in the X position and the Y position of the image to kind of offset the image depending on whatever X starting position and a Y starting position we have here, okay? So this should render our image to our screen. One thing I'm also going to do is I'm going to go ahead and get rid of, or just comment out, this random pixel thing we have going up here. If I compile, just to make sure this all works, looks like we have no errors in our code. So let's go back to game and actually call this render image. So what we know that render does, in fact, I'm going to go ahead and add a few comments here. What render does here is renders our pixel array to the screen. That's literally what it does. It renders our pixel array, or just our array of pixels to the screen. Render image. I shall put this in command format. Render our array of pixels to the screen. Render an image to, or I guess I could say, no, I'll say that. Render our image to our array of pixels. So, if you know that that's what both these methods do, we're going to want to call render image before we call the render method, right? So down here we have render in our in our game Java file. We're going to go ahead and call renderer.render image and pass in our test image, which we had as a field in this class. So we're passing in our test image, buffered image, into the render image method for renderer, and we are then rendering that onto the screen. Oh, another thing, we have to have an X and Y position. For now I'm going to make that 0 and 0. Okay. There it is. It's pretty small because it's a small image, but there's our grass tile all the way up there. And that's at 0, 0. Now if I go ahead and try our offsets here, let's try 100 and then 50. Yeah, 50 or something. There's our image right there, offset by these random numbers that I just entered in. So that's pretty cool. We have now got an asset onto the screen. Okay, so that's about where I'm going to end this kind of lesson, or this episode, this lesson, whatever you want to call it. What your challenge is going to be for next time. Now, if you want to, you can try doing this before watching the next lesson. If you're lazy and you don't want to try this out and you don't want to be a good computer scientist, you want to figure things out on your own, don't do this. But I'm going to go ahead and insert a few more parameters here for you. And there you go. This is going to be the X zoom of this image and the Y zoom of this image, right? So if we want the image to be rendered to the screen, but with zoomed to that X value and zoomed to this Y value, okay? So if this was 2, if X zoom was 2, the X would be multiplied by 2. So like it's almost like taking our grass tile here. We just go ahead and drag it in here. It's like taking it, if X was 2, that's what we get. And if Y was 2, as well as X being 2, that's what we'd get for X zoom and Y zoom. Okay? So that's what we're doing. That is your challenge for next lesson. Now, for you, those of you that are doing this, that are in school right now, these lessons are I'm probably going to do one each week. Or at least I'm going to upload one each week, so you can continue off where you started. But yeah, that is your challenge for next time. Try to figure out how to zoom the image in X and zoom the image in Y as it's being rendered to the screen. Now, one thing I want to tell you not to do is I don't want you to look up buffered image zooming. I don't want you to actually zoom the buffered image. I want you to figure something out down here as far as the X and Y goes of the image in the screen. Okay? I don't want you to, just please don't search zooming buffered image, because if you actually, what I know you're going to find is you're going to find something that's going to actually zoom the image, the buffered image, because there is something you can do in buffered image for that. But I want you to do it this way, because this is going to help you learn how to deal with image pixels, and it will probably be more efficient if we're doing this every single frame. So anyway, guys, thank you for watching, and I will see you next time.